Hello, everybody. Welcome to the 7th BRR training session for different ways to analyze within BRR. So I'll talk a little bit at the end, but right now I'll just hand it off straight to Pro Miles. So thanks, everybody.
Okay, thank you, Sean. Let me share my screen here. All right, so like Sean mentioned, we'll be going over a few different ways to analyze bridges in BRR. In the last trainings that we've done, we've mostly been looking at running analysis from within the bridge workspace, but there are a few other things here that are worth going over. The first thing that we will take a look at is running a non-standard gauge analysis. The distribution factors in AASHTO are, calibrated around standard gauge vehicles, but a lot of times with, permit loads and things like that, you'll have a need to run a non-standard gauge vehicle analysis. So with the training materials that were sent out, one of the tutorials is this one here. It's the distribution factor line girder analysis tutorial. And this covers how to run a non-standard gauge analysis. If you have a chance to skim through, there is some good information in this tutorial about how the non-standard gauge analysis actually works. The short version of it is essentially that when you run this type of analysis, the software will initially generate a 3D model of the structure and use that to determine appropriate distribution factors for that non-standard gauge vehicle, and then it'll use those factors to run a line girder analysis. So it's more of a simplified thing than running a full 3D analysis, and it's quicker. But that's kind of just the short overview of what the software is doing. So we'll start out just going through a demo on how to do this. Again, please feel free to follow along as we're going through this. The training licenses should still be active today, so if you want to work through this as we're doing it, and then as well, if you have any questions as we're going through this, please feel free to put them in the chat, and we will try and get to any questions that you may have. All right, so to run a non-standard gauge analysis, there's a couple of things we'll take a look at here. So for this example, we'll run the analysis on this training bridge 1, which should be included in just like the sample bridge database when you install the software. So this is a steel bridge, and it's a system model similar to the other model types that we've been talking about. To do the distribution factor analysis, you do need to have the entire structure modeled. So this is one of the reasons why we use the system models in BrR to allow for this, since it needs the whole structure to be able to compute those distribution factors. So once we've got our bridge model all set up and ready to go. And so basically the first thing that we'll do is create the non-standard gauge vehicle. So if we go into the library, we'll see, sorry, let me go back and we'll just show exactly how to get here. Okay, so from the Bridge Explorer itself, we can go to View and then Library, and this is where we'll see the library, same like what we've talked about before. We have like parapets and appurtenances and things like that. We also have vehicles down here at the bottom. So the standard gauge vehicles, sorry, hold on a second. Okay. So we've got our library of standard gauge vehicles, and this will include HS20, HL93, other kind of standard AASHTO loads, as well as your, agency defined vehicles once you've imported the vehicles and templates that are available. And so to create a new non-standard gauge vehicle, we'll just go here to non-standard gauge and new. And then we'll get this window where we can define our vehicle. So you can go ahead. So we'll go ahead and define this non-standard gauge truck. Um, and we do want to check these boxes over here. This basically is just saying that this vehicle will be available for these different analysis types. Um, and this will determine, whether or not that vehicle shows up in your analysis template when you've selected for the different rating method that you've selected. Um, so Okay, so we're basically going to start out with setting up the wheels and axles here. And we'll look at a schematic of this here in a second, and that'll make it a little more clear uh, what we're doing here. But basically, we're setting up the distance to. So we've got the distance to the first wheel here from the center of the non-standard gauge vehicle. And so this is basically what we're defining here, the offset of that first wheel. Um, and the offset of the first wheel here for the second axle, and then the spacing between the axles. So that's what we're defining when we're setting this up here. And then over here, you basically have the additional distances to the different wheels for each of the axles. So this is what we've got for the first axle. And then we just change the drop down here to select the second axle and then go ahead and enter the spacings for those wheels along that second axle.
And just a reminder, as Carolyn's doing that, if you have any questions as we go along, please just type them in the chat. Thanks.
Yes, thanks, Mark. All right. So once I set up the axle spacing and then the spacing of the wheels along each axle, I'm gonna go ahead and click save. Again, just depending on how you can resize these windows. There is a save button at the bottom, so make sure to click that. And then we'll see this truck come up here and it's now saved to the library. You can also view a schematic of the truck, which is really helpful for these non-standard gauge vehicles, just to make sure that the layout of it looks the way that you intend to. So this is the center line of the vehicle. This is the first axle, second axle, and then those offsets here. The one other thing to note just about this schematic, and Jeff, correct me if I'm wrong, but I believe that this is, I think, one of the only schematics that you will need to probably close it and reopen it if you're making updates here. Most of the schematics update live, but this one you will, I think, need to make your changes, save and close to see the schematic update.
Yeah, try pressing save after you make a change to it. Try pressing save, see what it does. I think the library doesn't have that. It doesn't have that update mechanism in it.
Yeah, so see that still looks the same there, but if I close it and then reopen it, we do see that it shifted out here. So yeah. So just wanted to point that out, just since in the other trainings, you know, the schematics are really helpful, especially, you know, for things like this to make sure that we're setting it up the way we want it to. So just wanted to point out that this one is a little different. So
Seems like that should be a maintenance item.
yeah. Okay. So we've got our vehicle defined here in the library. And let's see. Oh, I think we do have a couple of other. There's a way to change this view. Oh, here we go. Vehicle plan, axle 1, axle 2. That's what I was looking for. So, yeah, so we've got the layout here, and then we've got the spacing on the different individual axles. So again, good to review the schematics just to make sure that the information that's going in here is representing what you really intended to. Okay, so we've got this vehicle saved in the library now. And we'll go back into the bridge that we want to run this analysis for. So this is one of the things where, again, we've talked about bridge alternatives a little bit. You need the bridge alternative to tell the software, you know, what to rate when you're running an analysis from the Explorer. But you also need the bridge alternative because this is the level that you'll run the rating from when you're running that non-standard gauge analysis. And that's because it needs the entire structure definition in order to perform that analysis and determine those distribution factors. So if we expand out the bridge alternative and open up the superstructure that we want to run the analysis for, you'll see here we've got the alternative that has our bridge, and then we have this vehicle path tab. And so this is basically positioning the vehicle on the structure. Again, for these non-standard gauge vehicles, they're not, you know, like a typical lane width. So basically, you'll need to define the travel way and where, you know, where the vehicle is actually going to be located. So for this, we can keep this to how it's set here. So this is just saying it's going to be centered on the structure. You can also use this window to define an adjacent vehicle here as well. Oh, the other thing just to point out as well, there are some options here that you can, so aside from the vehicle path, this engine tab here will allow you to view some different properties that you can set for this analysis. So so like we said, it creates a 3D model of the structure, uses that to determine distribution factors to run the line girder analysis. So you have some settings here on how it creates the initial 3D model, and then you also have some options here on output that you can generate. And some additional things here as well in the ranges for that distribution factor. The other thing, again, just to point out, and I know we've mentioned this in I think all the trainings, but it is good to review that F1 help menu on stuff like this, just to get a little more information about some of the different things that it's looking for and things that you can do here. All right, so we don't need to make any changes in that analysis window, but this is where you locate it if you do. So it's the bridge alternative window, and then go over to engine, select the distribution factor structure properties, and then go to this properties window here. All right, so to actually run the analysis, we will keep this selected here because we'll be running the structure from this this point in the bridge tree so that it covers the entire structure. And then we can just go into the design rate tab and analysis settings. And then here, what we'll do is select the distribution factor line girder analysis type. So like we said, we've got the line girder, 3D, and distribution factor line girder is the one that we'll use for non-standard gauge. So then if we scroll down the list of vehicles, we'll see under non-standard gauge vehicles, you'll see the vehicle here that we created, this library vehicle, and we can basically select this this vehicle for analysis here. And again, when you do create that vehicle definition, you'll want to make sure that you check those boxes on the side here, this rating ASR, LFR, and LRFR. Otherwise, it won't show up, depending on the rating method that you have. And this is just because sometimes there'll be a vehicle configuration that an agency will want specific to a particular analysis type. All right, so we've got our vehicle selected here, and we can go ahead and click Analyze. And so you'll see in the analysis progress here, it's going through and building the initial model that it uses to get those distribution factors, and then it'll run like a line girder analysis for each girder using those factors. Okay. All right, so we've got our analysis complete here. And then you'll see this does look a little bit different than sometimes we run the analysis. So rather than going here, and we'll talk about this more in just a second here, but you'll see you've got this engine outputs is the one that's available here. You can go to that window and you'll see the advanced rating results summary report. And so this will basically show, give you the results on your non-standard gauge analysis. So this is summing up the rating factors that were generated here, as well as the limit states and pass fail. And then it's also going to tell you the distribution factors that it generated for this analysis. Now, looking here, we'll see this is a 4-girder bridge, and we ran the analysis with the vehicle centered on the bridge, and you can see that reflected in the distribution factors here. If you run that analysis with, let's say, the vehicle in, let's say, the very right lane of the bridge, you'll see that reflected in the distribution as well, because it's positioning the vehicle along the vehicle path that you specify, and getting distribution factors for that vehicle when the vehicle is running along that path. So this is basically our summary and results here. Now, if we close this back out, there is some additional information here that was generated in the output when we looked at the output options here under the engine tab. There are a number of other reports and things that are generated here. If you do ever want to dig a little bit more into exactly what it's doing. The other thing to note here, so we ran this analysis for the structure overall, since the software needs to look at, all of the structure as a whole to determine those factors. But you can also go back into members after you've run that analysis and select the member alternative. And then you'll be able to see the typical output here that you'd be used to seeing from the other types of analysis that we've run. Now, the tabular results and spec check detail within here are specific to a girder, and so that's why That's why we need to, this is basically looking at output for the structure as a whole. But then if we want to see the individual girder, we need to come in here and select the specific girder that we want to see those results for. And so you'll see that you can get this for whichever ones it is. So like there's our girder 1 results, and our girder 2 results. So these are all there, the same way as it is for other, analysis types that we run. And then similarly, you'll also have the spec check detail output. Again, this is going to look like it does for the other analysis types that we've run, but it does use the loadings that were generated from that non-standard gauge analysis to get the actual moments, shears, forces, all that stuff. And then you'll see the same spec check output that you would see for a standard gauge analysis there as well. Let's see. I'm trying to think if there's anything else on non-standard gauge. I think that mostly covers non-standard gauge analysis. There are a few other things that we want to kind of talk about a little bit here. And one of them, again, is just to take a second here and talk about where you can kind of see different outputs for different analysis. So the bridge workspace tree here is set up, like we said, it's set up such that you do have to select the member that you want to see those results for when you come up here to tabular results and spec check detail. This is all particular to that individual girder. Whereas when you run the analysis from the bridge alternative, that is the analysis for the bridge. So we have, a summary here, but then we go back into the individual girders to see results. One other thing, there's a couple of other ways we can run analysis here as well. I guess this kind of gets into a couple other things we're going to go over here with running analysis from the Bridge Explorer versus the Bridge Workspace, as well as batch analysis and load rating tool demo. So before we move on to that, are there any questions or anything on the non-standard gauge analysis? I'm not seeing any questions in the chat.
And none right now, but if you have any, just throw them in there.
Okay. All right. So, so when we're in the bridge workspace here, whether we're, sorry, 1 second.
Carolyn, one thing while you're doing that, I think one thing just to iterate, I know you said it, but it's very important for people to remember that you can only use non-standard gauge on the girder system, like the system bridges. You cannot do it on a line girder.
Oh, good point. Thanks, Jeff.
Carolyn mentioned it, but I think it's sometimes people forget, and then they're trying to do a non-standard gauge analysis and it won't, it doesn't work. So this is why it's important to build out system models whenever you can.
Yeah, exactly. Yeah, and I mean, like with the system model, like we said, you can do the non-standard gauge, you can do the full 3D finite element, but then as well too, being able to kind of like change the vehicle path for, especially for like overload or, non-standard vehicles, being able to do the precise like positioning of the vehicle and that kind of stuff can help you to get a little more out of your inventory of structures as opposed to just running that line model that'll typically kind of be overly conservative or look at the worst case for things. So,
and I know we're drifting a little bit off topic, but I would say when you model bridges, and I know everyone here is probably going to be using the template bridges, but you should try to avoid using line girder unless you must. Like I think if there's something that the software cannot model with a system, sometimes I've seen people create like lines. I don't know, Carolyn, if you have examples, but maybe sometimes whenever you need to do like a turning radius or something on at the end of a bridge, people create lines to simulate that.
Oh, sure. Like when if a girder is framing into a different girder, yeah, yes, there's scenarios where people will use those line models, just to kind of model parts of a bridge that can't easily fit within what is supported. But yeah, like uh, like you said, Jeff, I think, the vast majority of the time, system bridges is the way to go. All of the template models are set up based on system bridges, and as well when you're creating new bridges from scratch, it's definitely worth it to take the little bit of extra time and set up that system model. And like we said as well, you can copy these member alternatives from one to another. So when you're setting that model up, it's not really that much extra time. And to be honest, it's actually in some ways maybe a little bit easier because it'll allow the program to compute, the tributary like dead loads and stuff for you, compute live load distribution factors. So system model is the way to go whenever you can. But all right, so um okay. So as far as then the other kind of topics we'll be moving into here. Like I said, we'll talk a little bit about so this has all been analysis that we've been running from the bridge workspace. And again, it's either, for the bridge or for, the member. We've got the tabular results, spec check detail, engine outputs, like we've talked about. And again, keep in mind the engine outputs are different for different structure types. So it's always worth kind of checking through there. Particularly, and again, these are, we haven't, I think we did talk a little bit before, but culverts, trusses have their own kind of unique output here within the engine outputs, non-standard gauge. So it's always worth checking here for, because we've got different stuff that's relevant to different structure types. So, and then, we also have result. Okay, I don't know why that didn't work, but we also have results graphs here. Oh, it's because non-standard gauge. When you run a normal analysis, you'll have your results graphs here as well. So when we run the analysis now, we'll take a look at running the analysis from the Bridge Explorer. So this is going to be a little bit different. Okay. So I guess we'll start out, we'll just run one bridge from here to start out, just because I want to show kind of what the summary result here looks like. So if you select a bridge from the Bridge Explorer and then go over here to the Rate tab and go to Rate, you'll see the same analysis settings that we saw within the Bridge workspace. So for this, I'm going to just go ahead and run a regular line girder analysis, and I'm just going to put this vehicle in here as a permit truck. And I'll click OK, and then this will go ahead and run from here, and I'll just show you what the results look like when you run that. So this basically went through and it analyzed all of the girders that are in that bridge. Again, this is why the bridge alternatives and member alternatives is important, so it knows what to pick when you have multiple things in there. So once that analysis completes and you click this OK button, you'll see this window come up, and this will tell you the overall controlling rating for that bridge. And so this is saying, of all of those 4 girders in the bridge, this is the controlling rating factor. And so if you select that and go to structure rating results and member rating results, you can then see the rating factors for each of the individual girders. So you can see which ones are, controlling. In this case, the exterior girders are controlling. And then, like the controlling location. So this is really more, when you're running a bridge from the Bridge Explorer, it's typically more to kind of look at that bridge overall like this, or to run a permit vehicle or things like that. You from the Bridge Explorer, you don't have access to the full spec check details the way that you do when you're running the analysis from the Bridge workspace. So when you're in the Bridge workspace and you're, doing the actual rating, setting up that rating for the bridge, that's typically where you would probably want to see all those detailed outputs and spec checks and everything. Running the analysis from the Bridge Explorer is more, the overall results. So that was basically just kind of an individual bridge from the Bridge Explorer, but we'll demo a couple other things here real quick. So another thing that you can do from here is to run batch analysis. So I'm going to go ahead and select a few bridges here. We'll go with these three. And basically that's like a control and click to select multiple. So you hold down the control key and select the ones that you want. So these three that are highlighted here, I can come in here and rate, and we'll go ahead and run this again. And this is basically going to be a batch analysis for this group of bridges. And so as this is running, keep an eye here as well on the time that it takes to run it. It's not going to be too long because this is just 3 bridges. But when you are running the batch analysis, especially if you have a lot of vehicles in there, it can take a little bit of time. And that is where the load rating tool comes in, which we'll demo here in just a second. But this was a batch analysis that ran all 3 of these bridges here for the permit load that we were checking. So we click OK, and then again we see the results here. So we've got each of the bridges and rating factors, and then we can select, let's say, the specific bridge we want to look at, and again go to the member rating results. This one only has 1 member modeled, so that's not a good example. Let me go back to this one. And we can look at the controlling ratings for each bridge and for each truck. And again, you can, when you're doing this, you can put a whole bunch of vehicles in here if you want to. So if, let's say there was a new load configuration that was required, to be added, you can select a whole bunch of different vehicles and run that all at the same time for all of these bridges too. Let's see. So if I think, I don't know. Yeah, so if that was, like I said, the time it takes to run, let's say 1 vehicle, if I run the entire template, it'll take a little longer. But this is where the load rating tool comes in. So when we just ran that analysis, it basically went through and did a complete analysis for all of those bridges. So I ran the line girder analysis, so it did the 2D finite element model, created the influence lines, did the spec checking, ran the vehicles. But what we can do here to speed up things like permit analysis and things like that, we can use the load rating tool. So basically what the load rating tool does is when you go in and once you've got your bridges, done, they're set up the way that you want them to, you can generate pre-computed data for all of those bridges. And basically what that does is it'll run through an analysis and it'll save a whole bunch of information. It'll save information, as much information as it can with capacity calculations. There's some capacity calcs that are load dependent, but it saves as much data as it can to reuse for future analysis. And then it'll also generate and save influence lines for that structure. So once you generate all of that pre-computed data, you can then use the load rating tool to run an analysis for any other vehicle configuration. And it's a real analysis. It's not like an approximate analysis or a moment comparison type thing. It'll run that vehicle on the influence lines that were pre-computed and saved, and use as much information as it can from that initial analysis. And then it'll look at that live loading, handle any live load dependent capacity type stuff, and you'll get that analysis. So just as a quick demo on that, we'll select those same 3 bridges and go here to pre-computed data. One thing to note too is that you do have to go in and enable these. I think it's the don't remember exactly where to go and enable it. It's that configure.
The administration tool, the admin
Yes.
tool.
Yeah. Yes, the admin tool. But once these are enabled, basically what you do is we'll select those same 3 bridges here. And we're going to generate the pre-computed data for these bridges. So we'll do LRFR for these bridges, and I'm going to go ahead and click generate. Now, when I click generate, it's going to take about the same amount of time that it would take to just run, a vehicle over those bridges since it's doing the analysis. So I'm going to click generate, and we'll keep an eye on the time that it takes to generate. All right. So, like we said, that's about the same as it is when we run that analysis. Now, again, this is just 3 bridges. If you're looking at a bunch of bridges at once, that analysis time can add up, which is why it's helpful to be able to pre-compute this data and save it. So I can click OK, and we have our pre-computed data generated for those bridges. It is something that your agency will need to maintain. Basically, whenever you have changes to these bridges, you're going to want to go through and regenerate that data because it is going to continue to use that data when you're running stuff from the load rating tool. So, let's say if you have an inspection and there's added loads or deterioration or something, you will need to come in and regenerate the data for that bridge to make sure that you have up-to-date data. But again, that's not a very frequent thing that you'll need to do for most bridges. So we've got our pre-computed data, and then we can go into the load rating tool, and we'll say let's check a permit truck for these bridges. All right, so we've got our rating factors, we've got the bridges we want to run, and then we've got analysis settings here. So I did these LRFR, and I'm going to run let's see, we'll just pick a truck here. All right, so I've got that vehicle. All right, so all we do is just pick the permit vehicle we want to run and click process permit. And then we'll see this is again going to do a complete analysis for that vehicle, but you'll see it'll be a lot quicker since we have the pre-computed data. So here we go. I'm going to click process permit now. And it's done. So like I said, this is, just sort of a demo using just 3 bridges and 1 load, but this is a really, really helpful tool in the sense of being able to get, instant answers, particularly on permit vehicles. So once we've got that analysis complete, what we'll see here is, the results here for these 3 bridges. Now, there are different pass conditions that your agency can set within the load rating tool. So, and the load rating tool will iterate through those, starting with the least restrictive, and see what is required. So you'll see like on this, on these last 2 bridges here, we have passed with no restrictions, and we've got our rating factors that are above 1. So this means that it just ran that vehicle and did kind of a normal analysis on that bridge. And we got that rating factor. For the second bridge that we see here, we see denied and pass with conditions. And so basically it'll look at, running again, an analysis without restrictions. If that doesn't pass, then it'll look at that first condition. And so in this case, it's a speed restriction, which then means that you can set it to user reduced impact. And so then you get pass with conditions, and it'll say you can pass this vehicle with that condition. So this can be very helpful for getting quick answers on permit vehicles once you have your system and everything set up here. So let's see. I think that pretty much covers. Let's see. We talked about non-standard gauge, Bridge Explorer versus Bridge Workspace, batch analysis, and the load rating tool. So I think that pretty much covers it. Were there any questions or anything that anyone has on any of these analysis methods?
Hey, Carolyn,
Hey,
I'll ask a quick question if
sure.
people need to think a little bit. What types of bridges can the load rating tool do and not do?
Oh, good question. And I should know this off the top of my head. It does cover most of our structure types. There are a few that it does not. I'll look a little bit here and see if I can get you the exact ones.
Carolyn, hit
Yeah,
F1.
there's
Mark.
something in the help. That gives if you type load rating, if you go to search and type load rating tool, I think somewhere there we have a list of.
Make that a little bit wider, Carolyn, the contents.
Yeah, I'm trying
And
to-
then on the search tab, type load rating tool here, yeah.
Bridges. Um,
Mark, do we have a Confluence article about it?
I know it's in here somewhere.
Um,
This help right here is something we're going to be getting rid of in one of the upcoming versions because it is kind of obsolete. It's hard to find things in it, and
Yeah.
this will be replaced with an online help in the next few years.
I know this is in here. That's what's throwing me off a little bit right now.
Type in rating tool. Take a load out of the name. Just type in rating tool.
Yeah.
Then click. Type in, oh, maybe go to pre-computed data there. And click on the generate tab, on the generate button there. Yeah, it's not here either.
Go back to load. Click on the load rating tool. One right there on the left, and then double click on it. Sorry. Which version are you running?
751.
Okay, let me share my screen because I think this is in 7.6, and I can paste this in the.
Oh, okay.
Yeah, that's what I was looking for. I'm like, I knew it was in there.
I think we added it to 2.7.6. So this is what.
That may be why. Okay.
Yeah,
I was like, oh,
because
weird.
I think we actually have a Confluence article for this as well, and I could paste that in. But I'll put this into the chat. So you have it, but I think let me find the link for the Confluence article. But these are the types of structures that we do for LFR and LRFR.
And Thank you so much, Mark. Yeah, I knew that was in there. I was like, oh man, I don't know if I'm what's going
Yeah, I
on
think
Well,
that's
here,
what,
but
it's been a fairly common question, and I think we didn't have it directly specified in the help, so I think we added it for the last release. So
and that's another reason why we're going to move to online help, because once we send the software out, we can't update the help anymore, and people have questions, and it's easy to drop that with it. If it was online, we could update that, and
right, right.
yeah.
it would be
So the
updated in
one
real time.
the oh sorry. Yeah.
Good.
No, yeah. So I was just gonna say the one other thing that I do want to mention about this. So we have like we said, we've got this list here. Mark just put in the chat. We are also currently working. There's basically a project to we're working on planning getting all of the remaining structure types into the load rating tool that are supported in BRR. So it's going to be a little while still on the implementation of that, but that is at the forefront. And so we're doing planning on that now. So over the next several years, you'll see more and more of those structure types, and the plan is to get them all in there. Um, and then, yeah, like Jeff said, we are also updating help and everything. So,
Hey, Sean, have you guys talked about when you guys want to upgrade to the newer version of BRDR?
Not yet. We want to get through all the template creations first and
Okay.
and then we'll work on that. So it'll still be a little while.
That's okay. I mean, 7.7 is going to be coming out later this year, and it's going to have a lot of bug fixes in it. And obviously the help. I can see that even when Carolyn moves around in the 7.5.1, I can even see like there's like that little the units bubble that pops up. There's a bug that was fixed. That was fixed in 7.6, I think. So at this point, if I were you, I would wait at least until 7.7 because 7.7 is going to be coming out in a few months. So
Okay, sounds good.
yeah, and that being said, though, too, I think I mean, for like you said, for the purposes of using the same version for as you're working through the template creation, I definitely understand taking that approach to it just so that you're getting everything set up in the same version. And like Jeff said, 7.7 is coming out, although that one is more specific for a couple of features that VR
well,
well.
actually, I think 7.7 is more of like because there was an ADA. Some of the states are starting to
Mhm.
require proper ADA, and so we weren't going to have a release this year. I shouldn't say that we weren't going to have two releases this year. And we ended up having to do the 7.7 release for some legal things that a few states were popping up. But I think so far we've got over 100 some bug fixes in it. So even for that alone, I think it's worth getting. And plus you get all the cumulative bugs that were fixed in 7.6 as well. So if you guys are on 7.5 or 7.5.1, everything that was fixed after that will be available in 7.7.
Okay, thank you.
And if anybody has any other questions too, I mean, don't hesitate to shoot an email to brdr@promiles.com. That's our support email. I'll put it in the chat. And we'll be more than happy to answer any little questions that you have if you think about something after the fact, or if you miss something and you're like, oh crap, I forgot. Like we can certainly answer your questions. And another thing I would promote to those of you, especially the consultants, we have a annual user group meeting, and if you're new to the software, or even if you're seasoned with the software, I would definitely encourage you to start looking into that every year. It's a great way to network with, the state folks, and also just learn a lot about the software. It really it adds value to your company, and also obviously adds value to the client, to the state. So you'll find a lot of people figure out tricks and tips. They figure out ways to trick the software to do things that it wasn't that cannot do. So it's just a really good opportunity. This year it's hosted in Boise, Idaho. It's next week, this coming week actually. So it's right around the corner here. But yeah, we host it every year. And it's a really good event for load rating.
Yeah, definitely a really good conference.
I think it's the conference for load rating. I mean, I know there are other Astro conferences and there's other conferences, but this one's entirely focused on load rating and so it's a good meeting. I'll turn it back to you, Sean.
Great. Thank you. So yeah, if anyone has any more questions they want in the chat before we close, keep putting them in. But otherwise, I'll say this is the last of the virtual training that we're planning to do for quite a while. This should cover all of the basic material that we covered in the in-person training last December. We are going to do some more training later, but we want to give you guys time to get into the program, get more comfortable with these bridge types and the corrugated mill pipes and everything before we move on to the next topics, which are trusses, timber structures, and two girder floor beam systems. So those are kind of the next trainings we're looking at, but those are going to be quite a ways away. We want to give you time to get comfortable with the software before we jump into those topics. And if there's any other topics that you think would be good to have training, just let me know and we'll consider those as well. So I think that is all I had to say for here. So I don't see any more questions, but if anybody has anything else, we'll stick around a little longer. Oh, looks like you do have a question.
Moment and shear distribution factors are computed by dividing the 3D model moments and shears by the 2D model moments and shears. Oh, okay. Sure. So, um, so that's basically just saying, so in terms of when the non-standard gauge analysis runs, like we said, that basically
So
the
Carolyn, you may want to start over because I think the person that asked the question he stepped out for a second. He's back in now, so maybe you want to start over.
Oh, okay. So, sorry. Yeah, thank you. Yeah, so the question here was just to explain or talk a little bit about something that's mentioned in the tutorial. So it's moment and shear distribution factors are computed by dividing the 3D model moments and shears by the 2D model moments and shears. So basically it's what the software is doing. Like I said, this analysis is sort of partway in between a 3D analysis and a line girder analysis. So it'll generate that initial 3D model and it'll run the vehicle for that vehicle path and get the moments and shears, for each of the girders based on that 3D model. Then it'll look at the like a 2D model in terms of, whatever it would be just for it's essentially saying it divides out the load distribution that would be used for a 2D model and instead uses the load distribution for the 3D model. So maybe the way that that's worded is a little confusing, but it's essentially saying that it'll get those distribution factors from the 3D model and then use them for a 2D analysis. So it'll do the 2D analysis by dividing out the 2D distribution factors that would otherwise be used and using the 3D model distribution factors instead. I don't know if that explains it or if there's any other follow-up question on it. It is only for, yes, so this is only for non-standard gauge vehicles. Yes, that's correct. that is only for non-standard gauge vehicles. And the purpose of doing that for the non-standard gauge is because the AASHTO distribution factors that are used for the other vehicle types, aren't applicable for the non-standard gauge, since those are developed, around a standard gauge vehicle. So yes, this is only for non-standard gauge. All right, thank you.
All right, thanks everybody for coming, and I'll let you guys go. If anyone still has some questions, I'll stick around a little longer. But yeah, thanks everybody.
Thank you.